On 11.13, the final section. After this, it's all finals. So anyway, when we look at this, it's asking us to construct a line that is parallel to L that goes through point P. It gives us a hint to make a transversal first and use our compass to copy the angle. So what we're going to do, I already have this sort of set up here, is we're going to try and make a line. Going to try and make a line that goes through that point. I know you can barely see that point. I really wish they had like a point maker here. Anyway, so we have a point, and we're going to try and go parallel to this. So what we're going to do is essentially just copy this angle here. So I'm going to go here, and I'm going to make an arc, and I will steal this arc, and I'll go up to this point. I keep doing that there. There we go. And I want to steal this arc. So there we go. I now know that I have the same arc. And what I can do is measure this arc. So we've already measured angles, so we're going to essentially do the same thing here. So I'm going to measure this angle. I'll lock that in, and I'll go copy it here. Because what we know here is we know that these are corresponding angles, right? If you guys remember what corresponding angles are, corresponding angles look like, well, it's only true if the lines are parallel, but let's pretend these lines are parallel. We know that this angle on the top right is the same as this angle on the top right. So that's what we're doing. We're making a corresponding angle where this angle will be the same as this angle. If I just connect these 2 points here, that didn't go well. So if I connect these 2 points, I was like, why is that so far off? Like, that's because it wasn't through that point. Okay. So what if we go like this? Man, I cannot get, I don't know if it's like a pixel problem I'm having or what, but it will not let me draw this straight line. There, it's letting me get closer now. So it just, that's as close as it's going to let me draw. And I know those lines don't look very parallel. But we know because of triangle congruence that they are. Again, it's just because this isn't like a real point and it's not letting me hit it exactly that I'm having trouble with that. But essentially, we've copied the angle, and because we know that we have corresponding angles, that the lines have to be parallel. So we use that logic here, and we said, hey, look, this angle is the same as this angle because we copied it. Right? And since we copied it, we know that those lines have to be parallel. All right. Develop a strategy for constructing a square. I'll tell you, there's a lot of different ways that we can make a square. And here is one of them. So, and I don't want to imply this is the only way you can make a square. So I'm just going to go here, and I'm going to do a couple things here. First of all, I'm going to get a side length that I'm going to use. So I know that everywhere on this line, all right, is the same length from here to here, from here to here, here to here, etc. Well, I'm going to keep that, and I'm going to copy that over as well. So now, again, if we think about it, I know that this length is the same as this length, which is going to be important to me because I'm going to perpendicularly bisect it. So let me go here, let me change this color, and let me perpendicularly bisect this. Again, it needs to be a little bit more than halfway at least. So I'm going to go ahead and perpendicularly bisect this side. And that's going to be important because now if I connect these points, I know that if I go from here to here and connect that up here, that these have to have the same length, right? So I can go here and I can say, hey, look, I know that this is the same side length as this because they have the same radius. Well, I can use that logic over here and do the same thing because these lengths are not any different, right? It's a square we're talking about, so it doesn't matter if I connect this arc and this arc. I know that these side lengths have to be the same as well. All right, so if I connect here, if I go here and I say, all right, well, I'm going to go from here to here, I know that has the same radius. And if I go from here to here, I know that has the same radius. So I must have a square because I have a right angle and everything else is the same. So they have to be the same. Otherwise it wouldn't turn into a square. So that's one way to make a square. I will say this problem, kids show me a million different ways to make squares. Again, that's one of them. Again, I know I'm leaving out a lot of the triangle congruence here, just for everybody's sake. That's all in the intro video. So I think if you watch that intro video, you'll see all of this is based on triangle congruence, and all of this is based on corresponding parts of triangles that are congruent being the same. So we've done those two things. Now 1128 just asks you to make some of these things. I'm going to leave this for you, but you can try some of these things in class. I give the class time to figure out as many of these as they can. And then the last thing, it just basically asks us to prove side, side, side by taking this and rotating it and reflecting it and translating it so that it matches up and that we know that side, side, side congruent works. But we already know side, side, side congruent works from, I don't know, chapter 7 or whatever chapter we did it on. Anyway, that is the end of Integrated 1. Make sure you study for your final.